Great. I thank you, and sorry for the delay in getting started. My name is Rebecca Shire. I'm with the Nature Conservancy in New York, and this is Simha Leventhal, who works with me. He's our conservation information manager. He does all of our data management, all our GIS analysis. And I, on the other hand, am a biologist and have very limited knowledge with technology. So that's why we're hoping that you guys can help us out on this project and bring some cool ideas to help us get this toolkit built. So the project that we're working on, we call it the Climate Adaptation Toolkit for New York. And what you're looking at here is the process by which most conservation organizations go through to figure out what strategies they should be adopting to adapt to climate change, which we all know is already making changes in our environment and is only going to get worse over time. And there's a lot of factors we have to consider when we manage natural resources and the environment to figure out what should we be doing differently because of the changes that are predicted. And you can see it's this kind of a long process. We have to figure out what's going to change, how it's going to impact our resources. And we do a really good job of getting to about step 4, and then our process tends to fall apart. Step 5 actually. And then when we get to step 6, developing the actual adaptation strategies, this is when there's a lot of guidance out there, a lot of reports, but people have trouble actually adapting it to their local context. And then we have very little projects actually going all the way to step 7 and implementing and evaluating whether anything changed as a result of their actions. So our toolkit is really targeted at getting people to get out of being stuck at step 5, get into step 6, develop their strategies, and implement and finalize the process. And this project was funded with a grant from NYSERDA, which is the New York State Energy Development Authority. And this was just something that they pointed out in the original grant proposal, was that there's a lot of visualization tools out there and different modeling tools out there to look at climate change. But we really need to synthesize the information from those tools into something conceptual that people can really use to actually evaluate their impacts. So what we want this toolkit to do is to really improve decision-making processes for natural resource managers. We're going to provide access to all the spatial data that's out there. A lot of people have access to some data, but not others, or it's in 10 different places that they have to go to. So we really want to provide a single clearinghouse for all of that information. And then we want to help them select those strategies that are most appropriate to their goals and their location, and help them get that transition from planning into action. So this is how we've envisioned the final product, what we call the toolkit. It's got a couple components. We have all the data about our current status, what we know about what's on the ground right now in terms of the species and different habitats that people are conserving, the connections between them. There's something we call ecosystem services. Kind of a conservation jargon for all of the things that we get benefits from the environment, things like clean air, clean water, carbon sequestration. There's a whole long list of different services, and we're going to model some of those and incorporate that into the toolkit. And then we want to also do some projections, so looking forward, not to 2100 like a lot of climate models do, but just looking to 2050, because that's really the time frame that planners and managers can work on. And we want to project what's going to change with the climate, and then what do those climate changes mean for all of those resources that we mapped for the first step. And then finally, we want to provide those resources for implementation. Case studies, guidance on exactly how do you go through changing your timber management regime. There's a lot of detail within that strategy. And then connecting people with other practitioners, so having a social network where people can really find out who's doing what in the area, what's working and what's not, and get people talking more. So the toolkit needs to take all of that spatial data and create that node where people can go get the information they need, translate that into a decision support system that outputs some recommended strategies, and then based on the strategies that they've selected for their project, find the resources that they need to then go implement. And that's how we envision the toolkit working. And this is a long-range project. We've only just started this year. So this year we are developing this kind of conceptual framework of how it all is going to work. We're just completing an assessment of our user base. So we're talking to all of those natural resource managers in the state, planners, local government, state government, to find out what are their needs, what are they currently doing, what challenges do they have. So we're figuring out that profile of kind of our mental picture of our user for this tool. We're pulling together all of that baseline data, projecting the future data, and then probably end of next year we're going to start really building this toolkit. So we have some time to play with some technological solutions before we actually have to put it all together. So we've talked a lot about how this toolkit will actually get delivered to the users. And there's a lot of options out there. It could be a downloadable program. It could be an extension that you run through ArcGIS. It could be a more low-tech solution. It could be PDF forms that people fill out at their desk, or it could be an Excel spreadsheet. But we would really like it to be a little bit more sophisticated. And where we end up on this delivery is going to partly be determined by the technological options we have, but then also by funding and our ability to raise some additional money to really make this a slick online platform. So as I mentioned, one of the things that we have to do this year is figure out this conceptual framework, and we're in the middle of this right now, figuring out what are the different sets of questions that the tool will answer, and what are the data sets that we can pull in for all of that spatial data, and then how are we going to structure the way that those pieces interact? How do you use the data to answer the questions that people have? And so we've been talking to people to find out what the questions are. And we've been talking to professionals in conservation and nonprofits like myself, who work in government, who work at universities, or maybe doing work in research field stations that deliver information to practitioners. And we're also talking to the private sector. We're talking to timber companies and contractors that do work on roads, and people who really are having to apply this information on the ground. And these people are generally aware of and concerned about climate change. We don't have a lot of users who are saying, we really are skeptical about this whole thing. So we don't have to educate people about climate change up front, which is a good thing. These are also people who have a lot of access to GIS capacity, which we were frankly pleasantly surprised by. Almost everyone, if they're not a GIS user themselves, they have someone in their office or their department who is and can do work for them. They're almost all running ArcGIS, usually version 10, which is the most recent one. So we can rely on that kind of technical capacity when we build this tool. So that will help a lot to simplify things. The user that we're looking at does have really limited time and resources, so we need a tool that is really intuitive and that is going to be really easy for people to quickly get the information they need out of it and not spend a lot of time learning a complex process. And the users are also really looking for local downscaled information. They've seen the big climate models that are global in scale, that have huge variance. We don't know if it's going to increase by 2 degrees or 15 degrees. They want to know for their location how precise can they get it in terms of their local information and local recommendations. So we've been looking a lot at other existing tools that are out there. As I mentioned, there are a lot. I'm just going to show you a couple of examples of things that we like and we don't like that are already out there. I have the links here, but I'm just going to show you screenshots of a couple of these. The first one is something called the Yale Mapping Framework, and this is basically, it's funny, they call it a mapping framework, and it doesn't actually do any mapping. It's basically this table, which helps you to pick what scale you're working at. Are you on, working at a single preserve, looking at a population of a butterfly that is endangered, or are you working on a big landscape like the whole Adirondacks? And then they actually start you off with what is your strategy. So are you trying to protect biodiversity? Are you trying to protect the diversity of the geophysical setting, like getting a diversity of different slopes and elevations and soil types to get the most diversity you can of places? Or are you trying to, actively manage to anticipate some future change and maybe doing restoration or changing the course of a stream in order to anticipate higher flows? So they start you a little bit backwards and say, here's the strategy we think you're working on, and then they give you examples, and they give you, if you click on each of those description links, they'll give you a lot of data sources to go look at. But they're assuming you already know your strategy. So we felt like that framework is a little bit backwards from what we want to do. This is another tool that actually came out of our office at the Nature Conservancy. This is used for planning invasive species management. And it's a series of decision trees that basically walk you through the decision process about, for a given invasive in a given place, whether you should treat it and try to control it or not, whether you just be throwing your money away and never going to likely succeed. So this is a system that's all on paper. Again, it's actually being put online to be more interactive, but it's not at all spatial. So you have to have your maps of your project area somewhere separate and look at them and then select the right box on the decision tree. So we kind of like the decision tree structure, but this is, a little too simple and not interactive enough for us. This is another example. I'm actually forgetting where it came from, but it's intended to help communities figure out their level of vulnerability. So this is actually designed for people dealing with more infrastructure issues than the natural environment. But it's basically just in PDF format. And it's these tables, and it allows people to define for themselves what their thresholds of something that would be really bad would be. So what kind of storm would be a bad storm, and what would be a worst possible storm? And you set your own thresholds, and then you figure out, looking at maps of floodplains, where you have infrastructure that would be threatened by those kind of worst case scenarios. So this is something that anyone could do. They don't need to have a lot of technical capacity, and they can define for themselves what is bad, which I find kind of intriguing. But I think that we might want to be a little bit more helpful in setting our own thresholds for people who would just throw up their hands and say, well, I have no idea. I want you to tell me. But this is another thing that we could be looking at in terms of how do you structure this decision-making process. Now let's look at some more online tools. This is Takimo, which is a really long name that stands for something. It's produced by the USDA Forest Service, and it is a web map that basically just displays a lot of climate projection data. And one of the things I like about this map is that you can click on any location and it'll pull up this graph. So you can see, I clicked on roughly the Albany area, and it gives you the projection over time for all the different models, and you can compare, the variance between them. What I don't like about this tool is that if you look up at the list of map layers that you can turn on and off, I have no idea what most of those are. It takes a lot of thinking to figure out what those mean. And so most people are going to click around and turn all on and off, and I've done this myself. I've spent a lot of time trying to figure out how to get the information you want out of the system. So some people have done a little bit better job of user interface with the same kind of data. So this is CalAdapt, which was produced by the state of California. And they allow you to actually type in any location like you would for a Google address, and it'll zoom in and it'll give you a box, like it did over Los Angeles, and it'll pull out automatically the projection chart, the same data over time over on the right, and it'll give you some summary numbers, and it gives you the color map. Some downsides of this one is that it only shows one variable at a time. So we would like to potentially overlay things like sea level rise and temperature increases on the same map. And again, it's just delivering just the data, and it doesn't really provide any of that decision support that we'd like to see. So, while we love the interface of this, it looks really slick, it's a little bit light on content.
Right, not to take you off, but it's 12:50, so those of you who have stuff at 1, or not 1, 5 should go. Maybe not only get 1, so you have 10 minutes. We'll turn that up.
Okay, no problem. I expect people have to be places. So just one other map that I wanted to show is one that our office has been working on for planning the siting of energy infrastructure. And so this is a tool that, again, delivers just data. It doesn't have that user support, but it does allow you to look at a lot more information and overlay different data layers together. Right here, I'm actually looking at modeled species diversity in the blue, overlaid with the locations of existing wind turbines. So you can see where, people are tending to put wind turbines and where that might conflict with high biodiversity areas. So this is actually a system that we have already developed for the Conservancy, and Sim has been working with the developer, and we're familiar with the technology behind it. So we may choose to actually plug our toolkit directly into this map system, would be one option. But we'd have to add a lot to be able to get, again, that interactive decision support structure. So our dream tool, we're thinking, what would we love to have if we didn't have any constraints? This really should be an online web map. While a lot of tools out there can be downloaded to people's desktops and used that way, we really felt to be as accessible as possible. This should be online. We'd like there to be what I'm considering a kind of a hand-holding mode for people who just want to go in and have it really simple and get the answer that they need and get out. And so those people we want to walk through the decision support structure step by step, ask them simple questions, display the data they need, help them interpret it, and help them reach their conclusions. There also should be an advanced mode, because we have a lot of users who say, I want to be able to get the data and play with it and bring in my own data sets and put it overlay on what you have. So we want an advanced mode where people can create their own custom maps, bring in their layers, potentially even make it a data sharing site where people could contribute data that then anyone could access and we can all build on it together. And then having the opportunity to bring it onto their desktop and work on their own GIS system. So the key question that we really hope that all the smart minds in here can help us with is, how do we link all those non-spatial decision support tools that are out there, whatever format they're in, how do we bring that into this spatial data viewer environment and have them communicate with each other so people can pull the data that is relevant to make the decisions they need to make. So Sim is here to answer any technical questions you guys might have about how we currently operate and their data systems, or I'm happy to answer questions about the project conceptually, but we'd love to hear what ideas you guys have.
So what is GIS and ArcGIS?
No, so I'm assuming a little bit more knowledge than I should.
Yeah. Well, GIS stands for Geographic Information Systems, which basically is a technology that helps visualize tabular data. And GIS comes basically in three main forms. You have polygons, you have points, and you have raster, which is grid data.
Like that.
Exactly. And then lines are usually either points or polygons, depends. But those are the three main. And basically, what GIS does as a technology, maybe, it helps have it creates this relational database, the ability for spatial components to have a conversation with each other. So you can do all kinds of math, whatever's above, beyond, etc. Now, I'll just say a little bit about our tool. Our tool is a Java tool. So
You mean this one?
this tool.
Yeah.
So this is what we're most likely to use for the toolkit. So we're not talking about you guys coming in and actually developing a web map like Google Maps or that kind of style or like this, because we have that. We have the ability to take the layers, and the layers are basically those the GIS layers, the information that is spatial, and display it in many very beautiful ways. But we're looking for your guys's like knowledge and maybe developing with Java, maybe developing with Python, and plugging into what we currently have to connect somewhere between those strategy building tools that are pretty dry and on paper to something, to this tool that is visual and interactive. Second question. Anybody has another question?
I see what's being talking all the time. Is your code online anywhere, or like if you want to just take a look and start working through stuff?
So that is actually a great question, and thank you for that. We have, the code is not just online, because probably some of it is on different libraries in GitHub and all kinds of different places. But what we will offer the people or person who will work with us is you're going to have a relationship with our programmer. Although our programmer is in Colorado, so it's not going to be a face-to-face, but he's going to be able to guide you through our servers, the back end, and and then once the gap you want to be working on is identified, so you can just go ahead and do it, and once it's working and functional and all that, we'll just plug it into our server and have it run. Currently, this is running a wind map, so it's not the adaptation toolkit. But as we invested so much in this wind map, we feel that this also might be a good way to do the adaptation toolkit. But as Becky explained, the adaptation toolkit is really a decision support tool, and not only a visualizer.
Any other questions? All right, well, thank you for coming.
So we actually emailed the list serve, and if you guys would like to get in touch with us, you're more than welcome to. I'll also put a couple of cards of mine on the table, so you can email me directly, although through the list you can also email me directly. And if you have any more questions, we'll be here for another couple of minutes to take them.